If you're a beginner and you want to TIG weld sheet metal, this is the meat and potatoes of this. This is what you need to know. You got to know all of it. What's up, everybody? Welcome back to Make It Custom. I'm Carl Fisher, and today we've got a video on beginner TIG welding, everything you need to know to get started and to do the things we do in this shop that involve TIG welding. So we're going to cover sheet metal TIG welding. Like if you have to do a door skin or any kind of patch panel, how are you gonna do that? There is a ton of information on that in this video. We're also gonna go over TIG welding aluminum. We're gonna go over TIG welding steel and a few of the different types of joints that you're gonna use when doing that on this type of work. This video is gonna be using the Arc Captain TIG 200P AC/DC welder. We just got this in to try out and we're super stoked about it. It's an amazing machine and tons of information in this video. So don't forget to like, click subscribe, hit notifications. Let's do it. First thing I want to go over is the practical application of TIG welding when you're building projects like we do on Make It Custom. Where are you going to use it? What are the advantages? And is there still a place for MIG welding? Yes, there is. We'll get to that later. But let's have a look at some of our projects and where we've used TIG welding. So on something that you don't want a lot of spatter, you don't want to have to do a lot of cleanup, you want a small weld, that's something that TIG welding is very, very useful for. Let's take, for example, welding exhaust pipe. If you're gonna MIG weld that, it's definitely gonna be a large weld and they're not gonna be the prettiest, right? So on exhaust, like Elio's done on this 1930 Model A Roadster, welds are exposed, you're gonna use TIG welding. They're nice and small. The thickness of material is thin, so you can really control and be precise with your heat and deposit small amounts of filler to make up the weld. Whereas with MIG welding, you don't get to control the amount of filler. So you're going to be depositing whatever wire feed rate you've set on the machine. That's how much filler per second is going to be going down. Whereas TIG welding, you can just dab a little as you go, and you can adjust your temperature with your foot, if you're using a foot pedal, as you go. Another thing is that, like, look at how thick this material is on the flange versus how thin this material is. You can't tell how thin that is, but imagine that's like less than a 1/16 of an inch, and this is 3/8 of an inch. With TIG welding, you can be so precise with your heat and where you're pointing it, where you're pointing your arc, that you can kind of lean most of the heat onto the thicker piece of metal and therefore weld things that are thick to thin quite easily. Now, sheet metal is another thing that you would want to weld with TIG, typically if you're gonna hammer it, right? If we're gonna weld and then shrink, because if you watch the channel, when you weld anything, you're shrinking it. The heat expands, but it pushes the warm material into the cold material, and when it cools off, it actually ends up tightening back up and shrinking. So hammering your welds after you've finished welding will stretch them back out, creating a nice even panel again. So if you're going to be doing that with MIG, it's not really possible. You're gonna just deposit so much material that you're gonna have tons of material to grind off. It's gonna happen so quickly that the hot and cold kind of makes it brittle and the extra material deposited, so you're just not going to enjoy hammering out your weld if you're MIG welding. So a TIG weld can be nice, small, precise, tight fit, and is still soft enough that it can be hammered. Whenever we're TIG welding sheet metal, it is your best case scenario. It's closest to gas welding. And it is very similar in the fact that you're controlling the amount of filler and you're controlling the amount of heat. Where gas welding, you're bringing a flame closer and further away, but you're still depositing filler material with a rod. Whereas TIG welding, you are just having your tungsten arc be what makes your puddle and controlling your amperage with your foot, so your heat with your foot. The other ways that we can use TIG welding in our fabrication processes, and something that we do here is when we're doing any like tubing where we want just nice tidy welds, right? This is our planishing hammer that we have. We manufacture these. These are all TIG welded. I wouldn't want to see a MIG weld here because of how close in and how tight these things get to our components. We want to see nice, tight, tidy welds that are just clean and spatter free, right? This way we can manufacture our piece and we don't have to clean it afterwards. We've cleaned all the parts before welding, we weld it, and it's done. What we are using is going to be the Arc Captain TIG 200P AC/DC machine. This machine, I personally have not used it yet, and I'm excited to try it right now. I've talked to a few other creators and people that love it, so I'm assuming it's a pretty decent machine, and it's definitely a decent price. Like if this goes through and does everything we're asking it to do today, I really think that best bang for your buck. I really like our Arc Captain MIG machine, so we'll see how this one goes. It is AC/DC. AC/DC does mean that you can do AC frequency, like high frequency welding, meaning like aluminum, like non-ferrous materials. DC is for like steel, stainless, that sort of thing. So if you are sure that you're not going to do any aluminum welding, then perhaps just a DC only machine is right for you. Our Captain has those as well, and they will be even cheaper than this one. The AC/DC, I believe, at 200 amps is sort of, it's what I've always used. I've never had a machine larger than 200 amps other than a really big old Miller dial arc I had way back in the day. But for everything we do at Make It Kustom, I've never used a machine that has more than 200 amps. So for $650 US is what I think I saw it for sale for right now. That's a really good deal for getting into kind of a machine that will do everything on your project. We're gonna use this thing today, and we'll start off with like the most basic stuff, like plugging it in. All right, so the first thing I do like about this, and I've kind of played with it already a little bit, is that the screen's nice and big, easy to read. I'll tell you the truth, I didn't read the manual right away, and I just could feel my way through all the controls. It's only got a few buttons on it, so it's pretty simple. Right now, let's start off with, we're gonna do a bit of steel. We're gonna do 10 gauge steel. Right now it says AC TIG. We don't want that. We're gonna go to DC TIG. We're gonna go 2T or 4T or spot. 2T means trigger on, trigger off. 4T means trigger on, and then you're welding, you don't have to touch, and trigger off. 2T is what we want. It just means that we're just using it while we're touching it. Pulse, so pulse is like a yes or a no. What a pulse is basically it's what it sounds like. You turn the pedal on, and you have two different amperages. You've got a lower amperage and a higher amperage. Right now, we're gonna not use pulse and just the most basic setting. We're just gonna use our amperage. For 10 gauge material, which is approximately 120 thou, I will use about 120 amps. With steel, it's a great place to start is how thick is your material, and that's how many amps you can set your machine to. And then with a foot pedal, you'll have a variable range below that. Okay, so before we jump into it, I'm just gonna briefly talk about the head of this torch. This is probably what you're used to seeing as the most common TIG welding torch and cups. These are ceramic cups. They come in different sizes here to get you into smaller angled spots. Like if you need to get into, a roll cage tube or something like that, you can reduce the size of that. As far as your stick out of tungsten, with this type of cup, you can't have a ton of stick out because you have a small area of gas coming out to shield your weld. Argon is what we use, 100% argon, pure argon as the shielding gas for aluminum, steel, whatever. As far as the tungsten size goes, I'll use a 1/16 tungsten for sheet metal or 332 for like 10 gauge. And if I am gonna weld some big heavy stuff, I will up the size of the tungsten as well to maybe a 1/8 tungsten. Right now, this is a 332. We've got a number 6 cup. And if you were to draw a right angle from the edge of the cup to the tip of the tungsten, you want that to be less than a right angle. So you want this to be just shy of that. You don't want to go too far out. You might get a weld contamination or porosity if any oxygen gets into the puddle while you're welding. As far as my gas flow goes, I will have about a 25 to 30 cubic feet per minute. Square feet per hour. Oh. What? I don't know. Whatever it is, it's 25 to 30 on the little ball that goes up and down. Come on, what do you want from me? I'm not a professional here. All right, so I just got some 1/16 S2 filler wire. There's S2 and S6 are the most common for steel filler wire. S2 is a little bit softer. S6 is a little bit stronger. They're probably both fine for everything you're doing, let's be honest. But if you're doing sheet metal stuff, guys prefer S2 because they're gonna be hammering it. Chassis stuff, S6 is more common. It is really important to have your stuff quite clean when you're TIG welding. There's a lot more setup in TIG welding, I think. You have a little bit more settings, you got more things to consider. You've got to grind your tungsten to be sharp. Ooh, we should talk about that. Most welders now, you can just grind them totally sharp. You used to have to put a little flat spot on the end. With my old dial arc HF back in the day, like it liked having like a tiny flat spot on the tip. But for the most part, your angle of your tungsten, your sharpness, for me, I go like maybe twice its diameter, 2 to 3 times its diameter is how long the point is. Kind of a rule of thumb. And you can have a look there. It's just a sharpened pencil, basically. Don't overcomplicate it, you're a beginner. If you think about too many things, you're gonna like start analyzing all your welds, like, and it's gonna hurt your brain. Don't do that. Okay, the other thing is you really wanna be comfortable. When you're holding your TIG torch, when you're sitting, whatever weld you're doing, comfort is key because how stable you are is directly related to how comfortable your arms are and how much range of motion you have. So if I'm gonna do some kind of a joint here, I wanna make sure I can get as far as I wanna go before I'm gonna stop that weld. So if I want a 4-inch long weld, what I'll do is I'll get myself all set up. I'm not gonna hit the pedal yet, and I'm gonna try and move that whole 4 inches without, you know, reaching or whatever. So if I'm gonna do, say, a T-joint like this is very common. I'll do something like that. Do I want my angle like this, or do I want it in the direction of travel? You kind of want 45 degrees if it's a 90-degree corner. You want this to come in at 45 degrees, but you also want to angle in the direction of travel for a couple of reasons. One is that when you are angled in the direction of travel, that's where your puddle is. Your puddle becomes, instead of your puddle being a dot like this, if I angle in the direction of travel, now my puddle gets a little bit longer. With a longer puddle, now I have an area in front of the puddle, or sorry, in front of the torch, where I can dip my filler rod, okay? So if you go vertically like this, you have a really good chance of putting this filler rod directly into the tungsten, which you don't want to touch. It just doesn't work. If you do touch the end of the tungsten, it's okay, but you got to go sharpen that thing. So if you're a beginner, I suggest get yourself a pack of tungstens. Don't buy 1, buy 10, and sharpen them all, and have them all right here, because you're going to start swearing and be bummed every time you touch the tip, and you're going to do that a lot, I promise. Now I'm going to tack, just like MIG welding, if you ever heard before, like you tack hot, right? So I'll stab the pedal all the way down to get a tack, because right now the material's cold, everything's cold, so you need a little bit more heat to get anything to happen. Ooh, you know what? Something I noticed I already like about this machine is that the fan is not on 100% of the time when you start welding. It actually has a thermostat that will turn the fan on once it heats up enough that it needs to be on, and if it cools down enough, it will shut itself off, because there's nothing worse than hearing whoa like all day when you're not actually welding. So for our T-joint, I am angled approximately 35 degrees in the direction of travel, which is this way, and I am about 45 degrees this way. And basically what I'm gonna do is I'm gonna build my puddle, like I'll put the heat down, I'll see the puddle form, and then I'll add a bit of filler, move along, add a little bit of filler, move along, add a little bit of filler, move along, add a little bit of filler. That's how I'm gonna do it. So I'm gonna do about a 1-inch weld right now. So I just wanna make sure, can I do 1 inch steady like that? No problem, no problem. Oh, I just touched it. So my helmet is set a little bit too bright, so I couldn't really see what was happening there. I was kind of blinding myself. That's what happens when you touch the tip. Gets a little bit of a ball of build up on it. So I can give that a sharpen right now. We're gonna try and repeat the same weld, just better. All right. What I notice is that the arc is like really stable. Like the puddle seems quite sharp, if that makes any sense. Yeah, I do like the machine. Seems like it welds well, just as good, if not better than my last one. Let's give her another go here. Or should we go to outside corner? Let's try an outside corner. So same deal. I'm pointing in the center of the joint itself, and I'm gonna angle in the direction of travel. I'm kind of pulsing my foot a little bit. It's just sort of a habit of mine. I like to mechanical pulse. So as I dip, I'll add a little bit of foot pedal, and when I move over, I back off just a little bit. Because as you add filler material, the filler material is cold, you're introducing something that needs to be melted, right? So it needs a little bit more power. That would make sense when you're adding filler material. And when you're moving over, you're just moving, so you don't really need full blast because you're not adding any material. Here's another filler material that you might enjoy playing with. Silicon bronze is a lower melting temperature filler wire. So it's almost like brazing. It's not technically necessary for the steel to become molten for this to weld and adhere. It just saves you a little bit of warping. Also, it's great for if you're building up some material and it's easier to grind because it's soft. You can build up material around some bungs on a gas tank, on a motorcycle, and you could grind them all smooth, and you could do things like that with it. So check out silicon bronze. You can get it as a filler for MIG welding as well. I know it's very well used in body shops nowadays that are just doing collision repair for the same reason. It welds nice, gets a nice fill. Okay, we'll do a little vertical up weld and just see how it does. Oop, just touched it. But I'm going rogue, I'm gonna keep going. Yeah, it welds nice, vertical up. Okay, a little vertical down, 10 gauge. I did it again. Come on. That was some steel. I think let's jump into, let's do some aluminum, 100 thou. And this is what your radiators are gonna be made from. This is kind of close to what your tanks are gonna be made from. And we just wanna see how this welder does and if we can do a bunch of outside corner and T-joints on aluminum. We will go AC TIG welding. We will be using, I don't know, we'll try it at 150. We'll see what that's like. 2T, yes. Let's give this a shot. I have not welded aluminum in a very long time. So yeah, this will be kind of fun. I'm using 4043 filler rod. It's kind of a, you can use it for everything type rod. With aluminum, one thing I do remember is you always want to have the puddle first. If you're making your puddle with aluminum, you want to start the puddle before you dip. That might not make sense till you try it. Okay, the welder welds beautifully. It's me that was like very shaky in the beginning, and then I kind of found my flow here. In the beginning, I was kind of searching amperage. So I was like a little bit too cold, a little bit too hot, and then I kind of found the right amperage, and now my legs are even. Welding has a lot of listening in it. You know, when you're MIG welding, you want to hear bacon frying. When you're TIG welding, you want to be able to hear, or you don't want to hear when you touch things. You want to kind of take note of all the different senses. What you're seeing, what you're hearing, what you're feeling as you're welding. Those are all things that need to be consistent and you can remember. Basically, because aluminum is a metal that the molecules are a little bit further spread apart, it's a little bit softer, it's a non-ferrous material, the heat transfer happens quicker than steel. We had these two welds. I started welding here on the steel and I started welding here on the aluminum, and I'm touching the same spot. I'm gonna get burned faster with the aluminum because that heat will transfer to here way quicker. That's why aluminum acts very differently when you're welding it than steel does. Let's give it an outside corner joint. One thing that aluminum doesn't like to do, it's not impossible, but it doesn't like to fusion tack. Not impossible, but you will notice it doesn't always love to fusion tack. I'm really happy with that welder. I mean, I have not welded in so long, and to even make welds like that, I'm pretty stoked. Okay, we're gonna get into sheet metal now. Everybody asks me about TIG welding thin sheet metal. This is something that is not as hard as you're making it out to be, I promise. A lot of people have a lot of trouble with this, and I just wanna go over the key things that you need to know to make this as easy of a process as possible so that you're gonna want to do it on sheet metal. If you're MIG welding a panel together and you're butt welding two pieces and you have a little bit of a gap, that's probably okay because your MIG weld ends up depositing like a little ball of metal onto it that's kind of big and it can fill a gap. If you want to fill a gap with a TIG weld, you don't. I'm gonna tell you right now, you just don't want to fill a gap in sheet metal with TIG welder. One of the things, and the very first thing that has to happen, is that those pieces fit tight. Meaning that if you're putting a patch panel on, you're gonna wanna fit that patch panel as perfect as you can. Take note of the thickness of material. Like if you're overlapping it and then cutting a piece out, you'll have to, subtract the thickness of a piece of material so that it fits all the way in. Like you have to be quite accurate with the way your panel fits so that when you scribe the panel, I would use a Sharpie or layout die so that you can cover the area that you are going to be marking with the layout die or Sharpie, and then use a sharpened tungsten, works great as a scribe, to actually literally scribe out that material. You can then take a file and you could file the corners a bit, you can file these pieces. You want that piece to fit as perfect as you can. And the more time you spend on that, the better time you're gonna have on the welding. And the reason why I'm really talking to you about this is because that's how important it is if you want to weld thin sheet metal. The more you do that, you will get better at it and it'll become less of a big deal. Like you'll just know what you're doing and you'll be like, oh yeah, I've seen that before. When a panel fits like this, I need to take off a little bit more here. This is how I'm file fitting. you'll get better at that, so don't worry about it. Once you've got a joint that is fitting super tight, is the way that you tack that piece in. If I tack this piece right now on this end, and then try to fit the middle, I've already screwed it up. Because if I tack on this end and that end, and one panel is slightly above and one slightly below, by the time I tack those all together, it's gonna kind of bunch up, and one's gonna be too low and one's gonna be, too high. So what you must do when you're tacking is you start at one place and you just work from there. That's why all your fitting has to be so good. If you can trust your fitting, like it only fits this one way because it's so tight of a fit, then you know that if you can get that panel in there, it's going to fit that way. During that process of you tacking, something else is gonna happen. You're going to experience tack shrinkage. So what you need to do then is you tack, and if it tightens up to the point where your panels are pressing together too much or they wanna overlap, you have to take a hammer and a dolly underneath your tack, give it a whack, 2 whacks, like just hit just the tack enough to stretch the tack out a little bit to allow your panel to open back up and relax. I'm tacking probably every inch or so. I don't want to see any tack further than 1/2 inch to a 3/4 of an inch from another tack. Because when you are welding like that, you'll actually be able to see it. The panel wants to move a little bit. You don't want your panel to misalign because of the weld that's coming up on it and the warping that's already happening. Okay, so I'm gonna start tacking now. What I'm gonna use is, I've got a 1/16 tungsten. I'm gonna use 040 filler rod. There's another kind of trick of the trade, is that like, you do have to use a very thin filler. The advantage of using a thin filler rod when you're doing thin material is that now, like I was talking about before, you're not adding more heat than you need. So what I'm doing is I'm watching my puddle, because you can see it. I'm gonna be in the direction of travel as I'm welding, and I'm watching the puddle, and if the puddle looks like it drops a little bit, I'll add a little bit of filler. If you're a beginner and you want to TIG weld sheet metal, this is the meat and potatoes of this. This is what you need to know. You gotta know all of it. I'm gonna fusion tack this. It's getting a bit tight. Now we've got, a bit more movement on it. All right, we are looking pretty good. Another way to check that is you can take a piece of wire here and just kind of like roll it along your weld. So like I said, we start off with about 1 inch apart, but now we want to tighten up our tacks. I'm gonna probably split all of these, maybe even 2 in that one. Something I'm also gonna say is that I struggled with heat when I started TIG welding. I'll tell you a quick little story, okay? I worked at a drag race fabrication shop, and I was welding, and he would come say, "Oh, you're too hot." And I'm like, oh, what? Okay, so I'd turn it down a bit, and I'd try the weld again. He'd be like, "You're still too hot." And I'd turn it down again, and I'm like, it's so cold that I can barely make my puddle. Like, I'm sitting there, trying to make this puddle. This is like when I first started TIG welding. And I realized then that your heat and your amperage are not always correlated. If I want to have very little heat in this panel, for you to go quick rather than slow, you need more amperage. But more amperage makes you think like it's going to be hotter. It's not. It technically is hotter, but your panel isn't going to be hotter because you're going to move quicker. The other thing I'll say is that if you do decide to change your cup to those larger cups like you've seen people using, I use them as well. You can turn up your gas flow at the same time. Does 2 things, allows your stick out of your tungsten to be longer so that you can see better, get into smaller places, but that extra gas flow that is needed to allow you to have that longer tungsten stick out is also gonna help cool your panel. Think about it. When we're stack attacking with MIG, I'm using an air blower to cool. Well, the argon that's coming out of here is more expensive air. It's just cooling the material. I'm dropping a dab of filler
every 1/2 to 3/4 of an inch. We're not looking for the most pretty welds like we do with thicker material. We are just looking to get it fused and enough.
You can see exactly where I've added filler. Added filler there, added filler there, added filler there, added filler there. Otherwise, it's just a very flat weld. I'm very happy with the weld itself. This little spot where you see my heat change, that's the stop start. No matter what you do, this is warping it. You can't ask me, how do I do it without warping? Because it doesn't happen. We would have to hammer this out. But because it's such an even and consistent weld and consistent heat, it shouldn't be that hard to planish that out. There you have it. If you have any questions about this stuff, we do have ongoing discussions in our Patreon site for sheet metal shaping, welding, metal fabrication, general discussions. You're welcome to go on there, and we can talk about this in further depth. If you are interested in this welder, our captain has a link in our description, and you're welcome to go on there, jump on, check him out. It has gone and done all the things that I do in this shop, and it's done it well, and there's a few things that I do really like about it. The display is beautiful, the versatility of the machine, AC, DC, it has spot welding timer, it's got other, square wave, triangle wave, although me personally, I need to learn more about those and the applications that they could be improving for what we do. But as far as welding, 10 gauge plate, 10 gauge aluminum, and doing sheet metal, that's all we really get into here. Very happy with the machine, and to be honest, price point is like wildly good. I do recommend the machine as a great entry level, and further, I guess Make It Kustom shop is not technically entry, but it does everything we need to do. So if you're doing the same stuff as us, highly recommended. Love the welder, love the way it welds, and hopefully you've learned a few things about welding aluminum and steels and sheet metal from this video. I'd love your feedback, and love you to throw something in the comments or check us out on Patreon, japhandskustoms.com for any of our merch and that sort of stuff. And thank you for watching Make It Kustom, everybody. Really appreciate you. We'll catch you on the next one. Later.